Hello, hello. Welcome back for Chapter 4, Lesson 7. We are talking about triangle congruence, Cpctc. So we're going to figure out what that means today. But before we get started, let's go ahead and do our warm-up. So we have problems 1, 2, 3, and 4. So here's my friend the pause dragon. Remind you to pause your device. Go ahead and work out those problems. When you get done, press play and we'll talk about them. All right, see you in a bit. Okay, let's see how you did. So it says if triangle ABC is congruent to triangle DF, then angle A is congruent to what? And remember, whenever we have one of these congruence statements for triangles, it's giving us 6 pieces of information, right? 3 sets of corresponding angles that are congruent and 3 sets of corresponding sides that are congruent. So angle A is the first letter here, so that means it's going to be congruent to angle D here. So we'd say angle A is congruent to angle D. Boom, perfect. And then what about BC? So this is segment BC. So BC is the first, second, third. So it's the second, third letter here. So that means it's going to be congruent to the second, third letter here, which would be segment EF. So if you got both of those correct, great job. Okay, let's move on to the number 2. It says, what is the distance between these 2 points? Remember, whenever you're finding the distance between the 2 points, you're going to use that distance formula, which is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Memorize that. That is a flashcard. Okay, and then we just need to define our variables. So we have 2 points. This is going to be my first point, so I'm going to call this, right, this is an x and a y. But if I went x, y, x, y, we couldn't tell the difference between the two, so that's why I'm going to call this my first and call this x1, y1, and call this my second point, which would be x2, y2. It's just kind of like a label, so I know that this is, I'm just calling this my first point and this my second point. I could easily call this my first point and this my second point. It doesn't matter what you call them, but you're going to get the same answer. But this is what I'm calling them for this problem. So then we just substitute. So we have D equals the square root of x2 is -1 minus x1 is 3. That's squared plus y2, which is 5, minus y1, which is 4. And all of that is squared. Perfect, perfect. Now we just simplify. So, okay, remember order of operations, to do the parentheses first. So -1 minus 3 is going to be -4. That's going to be squared. And then 5 minus 4 is 1 squared. And -4 squared, -4 times -4 is going to be a positive 16. And 1 times 1 is just 1. So we have the square root of 17. And remember, square roots cancel out squared numbers. And there is no squared number that is a factor of 17. And when I write, like, when I say factor, what that means, like, let's say I had the square root of 12. Would there be a squared number that is a factor of 12? And the answer would be yes, because 4 is a squared number. Because remember squared numbers, 1 squared equals 1. 1's a squared number. 2 squared is 4. 4 is a squared number. 3 squared is 9. 9's a squared number. So 12 is the same thing as the square root of 4 times the square root of 3. And 4 is a squared number, right? And I can write 4 as 2 squared, right? And so that square root and that squared cancel each other out, otherwise known as Fruit Ninja. Do you guys remember that game where the fruit used to come and then you just have, it was like on a screen and you just go really, really fast. That's what I feel like. Whenever I have a square root and a squared, I just like Fruit Ninja. They cancel each other out, and you're left with 2 square roots of 3, which would be the answer for that. It's not the answer for this problem, but that's just what I was talking about as far as being a factor. Factor are 2 numbers that are multiplied by each other to get this number here. But that's not the case with the square root of 17. There are no squared numbers that are factors of 17. 17 is just a prime number. So that's it. That's your answer. So if you got that, great job. Okay, let's look here at the next problem. It says if angle 1 is congruent to angle 2, why is A parallel to B? Okay, so what do we have? We have these 2 lines. We have this, which is a lovely transversal. And so whenever I see that, I'm thinking, you know, alternate interior angles, corresponding angles postulate, alternate exterior angles. What's the other one? Same side interior angles. So I'm thinking about that stuff. Okay, so what I see with 1 and 2 is I see that they're alternate interior angles. But this wants to know why these are parallel. It doesn't say that they're parallel, right? And remember, when it says they're parallel, then if they're parallel, then these angles are congruent by the alternate interior angles. However, remember the converse? If these two angles are congruent, then you know that these are parallel by the converse of the alternate interior angles. So if angle 1 and angle 2 are congruent, why are these two lines parallel? They're parallel because of the converse of the alternate interior angles theorem. Boom. Shakalaka. All right, cool. Then it says, list the methods used to prove that two triangles are congruent. Okay, we can do that. Let's think about this chapter. What was the first section, right? We had, what were they? Isometries. So if you could prove that it was a reflection, if you could prove that they were two reflections of each other, you could show that they were triangles are congruent. If you could show that they were translations of each other, you could show that they were congruent. If you could show that they were, what was the other one? No, not dilations. That's bigger. That's definitely not congruent. Rotations was the third. Then you can prove that they're congruent. Or fourth would be any combination of any of those, right? Like multiple. Like if it was a reflection and a translation, or a translation and a rotation, or shoot, you could even have a reflection, translation, rotation. If you could prove that, then you know that those two triangles are congruent. Okay, so that was 4-1, right? And then what happened? 4-2, we had the definition of congruent triangles. I'll just say congruent triangles, like that. And we needed those 6 pieces of information, right? So 3 angles and 3 sides. So you needed all 6 to prove that the triangles are congruent. And then it came down to the cheat rules. Okay, do you guys remember the cheat rules? What was one? It was side to side. Side to side, we had side to side. And then what do we have? We had sassy. There were some sassy triangles. Side, angle, side. What else did we have? We had angle, side, angle. What are you guys thinking? And then we had what? Angle, angle, side. And then there was one more. It was the notorious HL, which only looks like it's 2, but the only reason why it's 2 is because it is a right triangle, which means that's the third one, that it has to be a right triangle. So right triangle, hypotenuse, leg. Do you guys remember all those? 1, 2, 3, 4, 5. Yes. So those are all the different ways in this chapter we talked about proving that two triangles are congruent. For this section, you're probably going to stay right here with the cheat rules. This is what you're going to use. But I don't want you to forget that these are also ways that we talked about proving that two triangles are congruent throughout this chapter, okay? So don't forget, because it's going to come back on the test. Okie doke, so let's go to talking about what this section is. Cpctc. Okay, so Cpctc, see how fast you can say that? Cpctc. Oh, I couldn't even say it. You couldn't even say it. Cpctc. Okay, that was better. Okay, so what that is, it's an abbreviation. It's abbreviation for corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. Okay, so let's see here. There's my C, corresponding. There's my P for parts of congruent. There's my other C. Triangles are congruent. Cpctc. Okay? Corresponding parts of congruent triangles are congruent. Okay, so what does that mean? It can be used as a justification and a proof after you have proven two triangles are congruent. What are they talking about? Okay, let's talk about this. So, with the cheat rules, how many pieces of information do you need? Right? For side to side, you just need 1, 2, 3, right? Side, angle, side, 1, 2, 3. Angle, side, angle, 1, 2, 3. Angle, angle, side, 1, 2, 3. HL, 1, 2, 3, right? So you need 3 pieces of information. So what happens is, let's talk about side, side, side. So let's say you have to do a proof, right? And for that proof, you have to prove that, let's just say, I'm making this up, angle A is congruent to angle B, okay? So you have to prove that for your proof, right? But what you see is you see 2 triangles. I'll draw them here. So, okay, I'm totally making this up. So this is A, this is B here. We'll call this, you know, D, and we'll call this C, and we'll call this F, and call this G. Okay, so what I see is that we'll say this is 10, and we'll say this is, you know, 12, and we'll say that this is 10. We'll say this is, you know, 8. Okay. Okay, so this is going to be 8, and then this is going to be 12. All right? So what we see is we have this side that is congruent, right? And then we have this side is congruent, BF to AD, but it's different, so I'm going to give it 2 hash marks. And then lastly, the 12 and 12, so you get 3 hash marks, right? So what I can do is I can say, oh, this looks like it's side, side, side. I can say that, what's this, BG? BG, side BG is congruent to, this 8 is congruent to AC, right? I can say that I need the 3. So that's one of my sides. What's the other one? Let's go 10. BF is congruent to AD, that 10. Okay, that's another side. And then the third one would be the 12. So GF is congruent to the 12 CD. Perfect. So I have 3 sides that are congruent. So I know that the triangles are congruent because of side, side, side. So I can say, you know, triangle ADC is congruent to triangle. Okay, so this is where I have to make sure I write it because it represents 6 pieces of information, right? So A, and I'm going to D, so that is A. I start at A. A is between 8 and 10. B is between 8 and 10, right? So that means A is going to go, so it's going to start with B here. And then I went AD, so I went the direction of the 10. So here with B, I'm going to go the direction of the F because that's where the 10 is. So it's going to go BF. And then ADC, then I go to the 12, right? So I go BF, and then it goes to the 12, so BG. Okay, and I can say that those 2 triangles are congruent because of side, side, side. Perfect, but the proof is asking me to prove that these 2 angles are congruent. Now, once I prove that these 2 triangles are congruent, right, and this is because it's a side, a side, a side, there's nothing about angles here. However, because I have used side, 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 and I've proven that these 2 triangles are congruent, what that does is it kind of like opens the door, right? So remember, there's, for triangles that are congruent, and I'm kind of running out of space, so just go with me on this. There's 6 pieces of information, right? You have a side, you have another side, you have another side, and then what do you have? You have an angle, you have another angle, and then there's a third angle, right? So what did we do when we were solving this? Well, we determined that there was a side congruent, and we determined there was another side that was congruent, and we determined that there was another, and that's how we were able to go side, 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 right? However, once we write this statement and say, oh, this triangle, because of side, 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 right, these 2 triangles are congruent, what happens is that is like a key that unlocks the door to these corresponding angles. And so what we can do is we can use Cpctc. Corresponding parts of congruent triangles are congruent, right? So corresponding parts of congruent triangles, there's 6 corresponding parts of a triangle. So any of those 3 that you find in order to prove that those two triangles are congruent, if you need to find an angle, like these angles have nothing to do with sides. However, once we prove that the triangles are congruent, it unlocks like the treasure box. And now we can say that these 3 sets of corresponding angles are also congruent, right? Because A is the first letter here and B is the first letter there. So then I can say, what this was for, I can say angle A is congruent to angle B. Why? Because of Cpctc. Corresponding parts, right? These are corresponding parts of congruent triangles. These are congruent triangles. So corresponding parts of congruent triangles are congruent. So that's the purpose of Cpctc. So no matter which of these cheat rules, right? There's only 3 pieces of information. So you need 3 pieces of information to prove that the triangles are congruent. And once you need 3 pieces of information, right? Once you prove that the triangles are congruent, whatever those 3 are, whether it's side, 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 angle, side, angle, side, angle, 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 side, or HL, right? What that does is once you prove that they're congruent by one of those cheat rules, that unlocks the door to the other 3 pieces of information of corresponding parts that you can also say are congruent because of Cpctc. Okay, so that's basically what you're going to be doing for this section. Okay, you're going to give information, you're going to prove triangles are congruent using one of these cheat rules, and then they're going to ask you to prove that one of those other 3 pieces are congruent, and that's how you're going to use Cpctc. Congruent parts of congruent triangles are congruent. Whew! All right, I hope that makes sense. Okay, we'll go over some problems and hopefully it'll make more sense. So, remember, side, 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 angle, side, angle, side, angle, 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 side, and HL use corresponding parts to prove triangles are congruent. Cpctc uses congruent triangles to prove corresponding parts are congruent. All right, cool. Let's go ahead and look at some examples. So let's look at example 1. Now, don't look at it. I know it's written there, but let's just kind of like think our way through it, okay? Okay, don't look. You're looking. Stop looking. Okay, here we go. This is example 1. It's an engineering application. So we have this picture here, right? And it has numbers. It says A and B are on the edges of a ravine. A and B are on the edges of a ravine. What is AB? Oh, what's this side length? Okay, so we have all this information. Okay, so what do we have here? So I see we have 2 triangles, right? And I'm not looking at this. Okay, what do I have? I have 2 triangles. I see that this side here is congruent to this side. I see this side here is congruent, but it's 2. It's congruent to this side. And I see there's an 18, but we don't have another 18 anywhere. What else do you see? Do you guys see vertical angles here? Which would mean that this angle would be congruent to this angle. And then what would we have? We'd have a side, this would be a side, this would be an angle, and this would be a side, and this would be a side, angle, side. So these 2 angles are sassy. They're congruent because they're very sassy triangles, or side, angle, side, right? So we have our 3 pieces of information, but what we want to know is what is AB? Which really is that 3rd triad. So if we set this all up and we said, oh, this side is congruent to that side, and this side is congruent to that side, and then this angle is congruent to this angle, like that would be because it's given, right? Given. And then these would be congruent because of vertical angles. Then we could say these 2 triangles are congruent because of side, angle, side. Therefore, because we have those 2 triangles that are congruent, we know that this 3rd side, because of corresponding parts of congruent triangles are congruent, we would know that this side here is the same here. So we know that AB is 18 miles. Do you guys see that? So it basically says one angle pair is congruent, right here. because they're vertical angles, and then 2 pairs of sides are congruent because their lengths are equal. Therefore, the 2 triangles are congruent by SASSY, or side angle side. By Cpctc, the third side pair is congruent, so AB is equal to 18 miles. So if we look at that, right, so we have a side, we have another side, oh shoot, we got a third side, right, 6 pieces of information. We had an angle, got another angle, we got a 6th angle. Okay, so what did we have? We had in the problem, we had a side, and we had an angle. Okay, so because of side angle side, once we say that those 2 triangles are congruent, it opens the door to these corresponding sides and angles also being congruent because of Cpctc. Okay, so for this problem, they asked about this side. But if they would have asked about these angles, we could have also said that those corresponding sets of angles would also be congruent because of Cpctc. All right, is it starting to make sense? Okay, let's go ahead and look at a different example right here. Check it out, example 1. Okie dokie. All right, it says a landscape architect sets up triangles shown in the figure to find the distance JK across a pond. Okay, so we have a pond here, it looks like, and we want to find the distance across the pond. We want to know what JK is. Okay, so we got a lot of information. Let's look and see what the problem is giving us. It looks like we have, what do you guys see? Do you see that these 2 sides are the same? Right, those are the same. Do you see that those 2 sides are the same? Yeah, they are. What else do you see? Do you see that we have vertical angles here? Yes, so then what do we see? What do we have? Do we have 2 congruent triangles? Do you know why? Side angle side, side angle side. Yes, these 2 triangles are congruent because of side angle side. Therefore, we can figure out this third side because we know over here it's 41, so that means that this must be 41 because of Cpctc. Whew! Okay, so let's just go ahead and write down all of this information, okay? So the first thing I'm going to write down is just the given information that MN is equal to 41. I'm going to use it at the end, but I'm just going to have it right there. Okay, so that's given. And then just start writing down the given information. So JL is congruent to LN, right? So JL is congruent to LN, and that's just given. And then we have the other side, which is ML is congruent to LK, or KL. I'll say KL. That's given. And then we have the vertical angles. So I'm going to say angle JLK is congruent to angle MLN because of the vertical angles theorem. Yeah. And now we have our 3, right? Side, side, angle, or side, angle, side, angle, side. So we can say that these 2 triangles are congruent. Now this is the part where you really have to make sure that you're writing it correctly, because you have to write it so those 6 pieces of information can be written correctly. So what I'm going to do is I'm going to start with L of this top triangle. Okay, whoops, sorry about that. I think I hit it. Okay, I'm going to start with L. And then I'm going to go in the direction of the 30, which would be to K. So I'm going to go LKJ. LKJ is congruent to triangle, and L is the same, right? So I'm going to go with L again. And like I went L to K in the direction of the 30 edge, so I'm going to do the same here. I'm going to go L to M because that's in the direction of that 30 that edge that is 30 feet as well. So LMN, LMN, and then boom, LKJ is the same thing as LMN, and that's how you write it. And why is that? Why are they congruent? Because of side angle side. Okay, okay. Now what do we want to do? Oh, we want to say that these two sides are congruent, right? We have two sides are congruent. This is the third side. So I'm going to say JK is congruent to MN because of Cpctc. And then I'm going to have to change the format, right? So JK is equal to MN because of definition of congruent sides? What was it? Definition of congruent. It's not angles. Definition of congruent parts. I think it's parts. Or angles, sides. I think it's sides. No, it's definition of congruent. What is it? Definition. I'll say parts right now. And then we're just going to substitute 41 in for n. JK equals 41. And that's just substitution. Or actually, that would probably be the transitive property of equality, actually. Transitive, this is transitive property of equality. And there you have it, right there. So yeah, that's it for example 1. I'll see you in a little bit for example 2.